Hola todo el mundo. Hi everyone, my name is Maciej Arciuch. I work at Allegro. I'm a senior software engineer. And today I would like to present to you our system for Clickstream ingestion, how it's been designed, how it's been implemented, and discuss a couple of issues it tries to solve. Allegro PL is the biggest Polish online auction company. We also have similar sites in other European countries. We're often called the Polish eBay, which is basically fine because that's what we do. But I think we're better because eBay tried to enter Poland in 2005 and it lost the battle and it never tried to come back. We have the lion's share of Polish market. We have like 15 million of registered users. 3 of them are active each month. And Poland has around 40 million inhabitants. So we have more users than people can vote actually in Poland. And we run around 2 million transactions daily. Similar number of new offers daily, and like 11 million of new images uploaded each day. So this is the scale. We're a big company, local company. We're not a global company. We don't operate at the scale of the Amazon, but still it's plenty of traffic to deal with. As I said, Allegro is an online auction company. And we understood that it is crucial for our business to understand how our users behave, what are their habits, how do our users actually use our site. And to learn this, we started to record and analyze the Clickstream. Clickstream is by and large, the stream of every event like entering a site, or scrolling, or clicking, or even holding your mouse pointer over something for a period of time. Actually, anything which can be valuable can be called a clickstream. And probably you know that many of these events can be extracted reliably from the backend. For instance, simple page views can be extracted from access logs. But not every such event. For instance, the scrolling is a good idea. You cannot record this from the backend. So that's why we decided to go with the front-end Clickstream. And every day we collect around 400 million of such raw Clickstream events from both web and mobile devices. We have tracking libraries for 3 major mobile platforms. And the data we collect have become a very important source of information, and many business decisions are based mainly on these data. We started our adventure with Clickstream around 2012 when we developed our first system, and it was a pretty solid piece of engineering. It was based on, like any other system from that time, it was based heavily on the HDFS. We had Apache Flume instances writing directly to HDFS, and some MapReduce jobs that analyze the data in daily or hourly batches. And as I said, it worked pretty well, but it wasn't perfect. I mean, for instance, waiting 1 hour or 1 day sometimes for some data is way too long for some kinds of applications. Moreover, we made a mistake by choosing CSV and JSON as our default data formats, because they are human readable, they are flexible, but they take a lot of space. They don't enforce any schema, and this turned out to be a problem. There was a problem which is somehow related to the lack of schema. And namely, it turned out that each team, and my team is one of such teams, gathers its data, puts it into HDFS, and actually no one else can read it because no one else understands it. There are some ambiguous column names, if any. The data is not properly documented, and so on and so forth. Only the owner of a given data set could do anything meaningful with this. So we decided to take the second iteration and see if we can do something better. And the good news is that each of these problems can be actually addressed separately. And with respect to high latency, we don't do anything more now. We just use a streaming framework, Spark Streaming and Kafka in our case. And this allowed for many new applications of our data by just actually doing nothing new. For instance, we have the security team, which can now detect frauds in real time. And this is very important because it means we have to pay less for our trick customers. We have a recommendations team and the search team. They can also provide better recommendations by taking into account the most recent activity of the user. So by simply switching to a streaming framework, and in our case it's Spark Streaming with micro-batching, we allowed for new applications. So that's really great and very easy and cheap. The second thing is the data format. As I said, initially we used CSV and Avro, CSV and JSON, and it wasn't a good choice. So we decided to switch to something else. Namely Avro. Apache Avro is a mature binary data format, well supported by the Hadoop environment. It's compact, space efficient. It's schema-based, so it allows us to enforce a schema. And every schema definition has a place to put some column comments. And this is very important because later we can do very interesting things with this. Avro is also very cool for us because it allows us to, it can be used in, the same Avro encoded data can be used in both streaming and batch processing. The format is exactly the same. And very nice property of Avro is that you can reason about backward and forward compatibility by just analyzing the schema versions. There's a strict set of rules stated directly in the Avro specification. You just need to follow. Moreover, there is software which can do this for you, do this job for you. So that's an excellent piece of software. And by just simply using Avro, switching to Avro, we saved disk space, we saved CPU cycles, and now our data is much better described. But using Avro itself doesn't completely solve the problem of the one I mentioned, the problem of using data by other teams, namely, suppose you have a schema and you have some clients of them. Actually, these guys see your data and they actually wonder, do I have the correct version schema at all? Who is responsible for this data set? And there is a lot of meta information which is scattered in instances of schema which are sometimes compiled into some projects. And if you want to change something, you don't know what should you compare the new version with. And to address this problem, we decided to go with a thing which is actually not new, but it's not frequently used with respect to schema and metadata. Namely, we decided to create a single central repository for all the metadata, and which would become the single source of truth with respect to schemas in our case. And we instructed every part of our software to use the latest schema version. And all the people also in the company are told that there's a schema version, and you should always refer to the newest one. And this is very convenient for us, but it's not so easy to achieve. You can work this way only if you maintain the strict compatibility, forward and backward compatibility in your schemas. And you can do this only when you keep the previous version in your repository, so you know which version should you compare with. And we have also validators, which make sure that this compatibility is maintained when we commit a new schema version. And information from this repository is propagated only one way to other things. For instance, the Hive meta store. We copy all the column descriptions to the to the table description. So every time you enter Hue, you can see this data. And we also generate HTML documentation out of this. So it's really, really cool thing to have. This is the diagram of our system. We have the client-side version with the tracking libraries for both web and mobile devices. We have collectors, which are simple endpoints which simply gather the data, and we have Spark streaming jobs, which extract this data, they validate it, transform, and serialize into Avro binary form. And every other piece of software uses the latest schema from the schema repository. That's why it is very easy and to comprehend, and everybody and everything refers to the newest schema version from the repository, and after 1 or 2 seconds, the data appears in the destination Kafka topic, and after 1 or 2 hours, it's dumped by LinkedIn Kami, and new partitions are being created. As I said, Spark streaming is an important part of our solution. It's not a perfect one, but it's really solid building block, and if you're happy with the micro batching and you don't mind the complexity of Spark itself, it's a really, really good choice. So I think I'm running out of time. So if there are 2 things I would like you to remember out of this presentation is that Kafka, Avro, and Spark, they don't bite. They are really solid building blocks, and you can achieve a lot in a relatively short time. And if you experience such organizational problems, schema, compatibility issues, you are afraid that if you change something, you might break somebody else's computation, then you should definitely deploy a central schema repository and stop embedding some schema versions into particular pieces of software you have. Just let every software download the latest version and make sure that these latest versions will be backward and forward compatible. And this way, it makes your life way easier. And we use this way of working in Allegro, and it's been really, really successful. So thank you very much for your attention. If you have any questions, I'll be happy to answer them, probably later, because there are next talks going on. So thank you very much. Please check out our technical blog and our GitHub repository, because we have tons of interesting internal projects that were released, and I'm sure you will find something interesting for you. Thank you very much.